Consumers are moving away from the traditional search index. The standard list of blue links is rapidly being replaced by AI answer engines that respond directly to our prompts. In the physical world, Ivan Smith Furniture is a massive operation. It is a 68-year-old retail powerhouse, dominating Texas, Louisiana, and Arkansas with over 40 physical locations. But to the AI gatekeepers that now curate what consumers see, this physical empire barely registers. This chart shows the severity of that disconnect. The brand's digital infrastructure has an AI knowledge graph score of just 22 out of 100, registering only 2 entities. A knowledge graph is a back-end database search engines use to understand real-world entities and the relationships between them. For an AI to consider citing a brand, that score needs to sit above a 60. This failing AI visibility score is an existential financial liability that actively bleeds market share to national competitors. The cause of this digital invisibility is entity fragmentation. Entity fragmentation occurs when a business's data is improperly coded or scattered across its website, confusing search crawlers. Here, it is caused by deploying a generic monolithic web architecture across vastly different local markets. This diagram shows the algorithmic collision paralyzing the brand. Even Smith operates 2 distinct stores sharing the exact city name, Mansfield, Texas, and Louisiana. Housing both on a single URL forces web crawlers to parse conflicting JSON-LD schemas simultaneously. JSON-LD is the standardized code format used to feed structured data directly to search engines. Third-party mapping APIs and real estate aggregators subsequently scrape this overlapping data and incorrectly assign proximity markers. This corrupts the geographic coordinates and degrades the location's algorithmic trust score. When an AI engine encounters conflicting geographic and entity data, it defaults to ignoring the business entirely to avoid a hallucination. A hallucination is what happens when an AI confidently presents false information as fact. By causing this doubt, the brand is locked out of the discovery phase. The architectural solution to entity fragmentation requires transitioning to a decentralized network. This schematic illustrates the transition to a Verinode structure. A Verinode is a highly localized, machine-readable data hub engineered for generative engine optimization, or GEO. GEO is the practice of structuring content specifically so AI models can easily ingest and cite it. These hubs require liquid intel. Rather than feeding the AI generic, manufacturer-provided stock copy, the system provides hyper-local brand knowledge. Embedding exact GPS coordinates, local landmarks, and localized inventory data anchors the business to a mathematically undeniable physical location. Establishing this isolated, conflict-free data hub forces AI agents to recognize the local store as an authoritative, verified entity. Modern AI engines use Retrieval Augmented Generation, or RAG. RAG is a framework that allows an AI to search external databases for relevant chunks of text to formulate its answer. If content is trapped in unstructured paragraphs or PDFs, the AI will skip over it. The data must be rewritten using the bottom-line Upfront methodology. Core answers must appear in the first sentence to satisfy the extraction logic of large language models. Large language models are the neural networks that process text to power AI search engines. This code breakdown shows the required HTML formatting. Converting a standard text paragraph into a structured definition list makes that information 30 to 40% more likely to be cited by the AI. This perfectly structured data is then pushed to third-party platforms. This isolates the core thesis. This creates consensus across the web, building the external trust anchors AI models require. Unlike paid advertising, which stops the moment the budget is gone, this architecture trains the AI. It creates a permanent digital asset that retains the memory of the brand's local authority. We can track the real-world financial yield of this architecture by looking at the Mansfield, Texas operational theater after optimization. This dashboard reveals the primary performance metric. In just a few months, the location generated $733,120 in estimated lead value from 2,291 high-intent actions. To prove this conversion math, we zoom into a single micrometric pulled from that pool, 56 specific direction requests. Those 56 digital requests yielded 18 physical store visits. Converting at 33% with an average ticket of $1,500, that single metric generated $27,000 in net new revenue. This isolates the core thesis. AI optimization directly intercepts high-intent digital queries and converts them into physical, trackable showroom revenue. Expanding this proven math across the entire Ivan Smith network allows us to model the 10-pull strategy. This equation projects the macro math. If the architecture pulls just 10 new visitors per month across 43 locations at the standard close rate and average ticket, it yields $222,750 in monthly revenue. Deploying this system network-wide generates a 1,052% return on investment. The break-even floor for the boardroom is absolute. The entire network-wide infrastructure pays for itself with only 13 sales. That is just one sale every 3.5 days across the entire company. Urgent. Time is the ultimate currency in the AI era. Delaying infrastructure updates means forfeiting digital equity to the competitors who train the models first. Own the data, own the AI, own the market.